The second part of Lesson 3.2 is all about applications. What we'll do today is create and solve systems of equations from real-world situations, and then we'll determine if the solution that we found is reasonable. When solving word problems, follow these key steps. The first thing you'll want to do is read the problem carefully and underline key information. That may require you reading the problem more than once. You'll want to identify variables to represent the parts you want to solve. Once you've done that, read through the given information to create a system of equations. The solving methods that will be most proficient for us, or efficient for us, I should say, would be substitution or elimination. Graphing won't be useful in word problems as a lot of the values that you're working for or looking for have solutions that go off a coordinate system. Last but not least, check to make sure your solution is reasonable. Think about getting decimals or fractions, and if positives or negatives, do those make sense to the question being asked? Let's go ahead and try some word problems together. Here's our first problem. A hair salon receives a shipment of 84 bottles of hair conditioner to use and sell to customers. The two types of conditioners received are type A, which is used for regular hair, and type B, which is used for dry hair. It says type A costs $6.50 per bottle, and type B costs $8.25 per bottle. The hair salon's invoice for the conditioner is $588. An invoice is just what they're going to pay total for all of their kind of merchandise. How many of each type of conditioner are in the shipment? So taking a look at maybe underlying some key features. I know we got 84 bottles total. There are two types of conditioner, type A and type B. I think we'll be able to use those for our variables. Let's let A be the bottles of type A. And then we'll do the same thing for B. So we'll use A and B instead of X and Y this time. If you want to stay consistent and use X and Y each time, you're welcome to do so, as long as you identify which variable or which type of conditioner represents X and which represents Y. Let's see, it says there's a cost involved. So we've got a cost function as well. Let's take a look here. Type A is $6.50. Type B is $8.25. So as we look at trying to kind of make a connection here with the other numbers in the word problem, we know that there are 84 bottles total. If some of them are type A and some of them are type B, we can write an equation for the number of bottles that the salon received. All of the type A bottles plus all of the type B bottles should equal 84 bottles total. For the price, though, we know there's an invoice of $588. That's how much they spent on all of the conditioner. But A and B have different values. So if we do a price equation, type A is only $6.50 a bottle. If we take $6.50 times A, that would be the total invoice represented by the A type of conditioner. B, we have $8.25 per bottle. Together, that would be a total on the invoice of $588. Taking a look at the green row and the pink row, we have a system of two equations. A plus B equals 84. 6.5A plus 8.25B equals 588. Once you create your system, solve by either substitution or elimination. As I look at this, I know substitution would probably be pretty easy. I'm going to go ahead and try elimination though. I notice that I have my A's and my B's kind of in each column. If I multiply the top equation by negative 6.50, I'm just going to write right over this here. That will give my A column the same coefficient and an opposite sign. So right below, I'm going to write negative 6.50 times A, and then negative 6.50 times B. And on the right, if I take negative 6.50 times 84, I get a total of negative 546. Adding the columns together, column A cancels out. In the B column, I have 8.25 minus 6.5. That gives me positive 1.75. On the right, 588 minus 546 is positive 42. To get capital B by itself, which is the number of bottles of type B conditioner, I'll divide both sides by 1.75. Cross that off on the left, over here on the right. 42 divided by 1.75 is 24. That means there are 24 bottles of type B conditioner. To figure out A, I'm going to take that information and plug it back into the green equation. A plus 24 equals 84. Pretty straightforward to get A by itself. We'll move 24 over, and we get A equals 60. I had to zoom out a little bit so that we could write our final answer. For this answer to be reasonable, let's take a look at our final solution. We were asked how many of each type of conditioner are in the shipment. So we know that there are 60 bottles. That's a T there. Oh boy, hang on. I was going to rewrite this. 60 bottles, there we go, of type A. And there are 24 of type B. Make sure to label your answer. Does our answer seem reasonable? We have whole number amounts of bottles. They're both positive. I think we're in good shape. Let's try another one. You and your sister decide to combine your weekly overtime earnings to buy a birthday gift for your mother. Your overtime rate is $18 per hour, and your sister's overtime rate is $24 per hour. The total amount earned for the gift was $288. If you worked 2 more hours of overtime than your sister, how many overtime hours did each of you work? All right, boy, let's see what we have here. So we're doing some overtime. It's you and your sister, so that should be our 2 variables. I'm going to say let X be your hours and Y be your sister's hours. Okay. Your overtime rate is $18 per hour. That means if we take 18 times X, that's the amount of money you make in overtime. Your sister's rate is $24 per hour. So that means each hour your sister works, there's an extra $24 towards your mother's gift. Now it says the total amount for the gift is $288. So in this equation, we would want to generate a total of $288. Now it says if you worked 2 more hours than your sister, so you is the X. If you work 2 hours more than your sister, 2 more hours means you'd be adding 2 to the amount of hours your sister worked. That would be Y plus 2. So if your sister worked 10, then you worked 12. Let's see. So it says you worked 2 hours more than your sister. How many overtime hours did each of you work? So this is our system. We have 2 equations with 2 variables. Notice in that second equation, X is by itself already. So if we think solving by either substitution or elimination, it looks like elimination would be the way to go. Sorry, bring that back. Substitution, that would be the way to go. In that first equation, there's X, and in the second equation, we said X was equal to Y plus 2. Let's substitute that in. If we take 18 times Y plus 2 plus 24Y is equal to 288, we only have one variable in that equation. Distribute the 18 in, that gives us 18Y plus 36 plus 24Y equals 288. Combining like terms, 18Y plus 24Y would give us 42Y. And if I move 36 to the other side, we would get 42Y equals 252. To get Y by itself, which would be the number of hours your sister worked, Divide both sides by 42. 252 divided by 42 would be 6, meaning your sister works 6 hours. If we recognize that you work 2 hours more, then you would work a total of 8 hours. So to answer the question, how many overtime hours did each of you work? You worked 8 hours. Wow. I am just writing not as fast as I'm thinking in my head. Sorry about that. So you worked 8 hours. Your sister worked 6. That would be the solution to that application problem. Do those answers seem reasonable? We have whole number hours. They're both positive. I think that seems like a reasonable amount. We're going to keep going. The sum of two natural numbers is 314. The first number is 16 less than twice the second number. What are the numbers? Okay, here we go. All right, sum. Sum is the answer when you add. We're going to add two numbers together to get 314. So we have a first number and a second number, it says. We can pick two variables. I'm going to pick x and y. You could pick f for first and s for second, I suppose. But I'm going to go x and y. I'll let x equal the first of the two numbers, and y is the second number. If their sum is 314, that just means we're going to add the two together. So that's an easy equation to generate. X plus y equals 314. It says the first number is always a good divider from one side of the equation to the other. So the first number is, that would be x equals 16 less than, that means we're going to subtract 16 from something. Twice the second number. If it's twice the second number, that means we're doubling the value of that second number. To write that second sentence, the first number is 16 less than twice the second number. If we think order of operations, we need to double it first and then subtract the 16. There's our system. The sum of two natural numbers is 314. The first number is 16 less than twice the second number. To solve this system, I'm going to let you try it. Pause the video and solve. When you're done, press play and we'll see if we get a match. You're welcome to use substitution or elimination if you move the 2y to the other side. All right, let's see how you did. I stuck with substitution since x was already by itself. I plugged that into the top equation and I got y is equal to 110. Now, a natural number is like a counting number, so fractions or decimals wouldn't seem reasonable for this solution set. 110 is a natural counting number, so we're good to go there. Using the substitution method, I had to go back and plug 110 in to get the other variable, and I got 204. Now, even though we identified these as x and y, you actually could write your solution in either order. This isn't necessarily an ordered pair to an equation on a graph, but our two numbers are 204 and 110. All right, I'm going to help set one more up with you, and then you'll have a little bit of homework for tomorrow. Tom is currently 3 times Jerry's age. In 9 years, Tom will be twice Jerry's age. How old is Tom now? All right, let's take a look. So we have Tom and Jerry. I guess T and J would seem reasonable. T will represent Tom's age, and J represents Jerry's age. In that first sentence, Tom is, T equals 3 times Jerry's age. That would be 3 times J. In 9 years, Tom will be twice Jerry's age. Here's the thing about 9 years. In 9 years, not only will Tom get older, so that would be T plus 9, but so would Jerry. That would be J plus 9. They both get 9 years older in 9 years. But how they compare to each other is that twice. It says Tom will be twice Jerry's age. So the left side is equal to 2 times the right side. Let's try this again. Tom is currently 3 times Jerry's age. T equals 3 times J. In 9 years, Tom's age will be twice Jerry's age. So here's their ages in 9 years, and there's the comparison with each other. Tom's age will be twice Jerry's age. How old is Tom now? So this is what I want you to do for your homework. I want you to actually solve this system. And we'll go over it in class tomorrow.